Number 62. Hydrogen iodide, which is Hi, decomposes in the gas phase to produce hydrogen, which is H2, and iodine, which is I2. The value of the rate constant, which is K, for the reaction was measured at several different temperatures, and the data are shown here. So here comes the question. It says, what is the value of that activation energy in kilojoules per mole for this reaction? Okay, now, there's a couple of ways to do this type of problem, especially if they give you temperature and rate constant data. Now, one way would be to do the full scope of this, where we would have to graph these values on our on either our lovely and trusted Calci, or draw it out on paper. But there is an easier way, which we are going to do today, and it's always coming back to a formula, right? Now we're going to assume this will only work if we're going to assume that these temperature and rate constant values, when they are graphed properly, will produce a linear line. Now, the units, temperature, and the rate constant, they are not going to be the ones that will produce you a linear line. The idea here is that you will get a negative linear line, something like that. I mean, maybe we'll do it a little bit like that. That's good to go. And the units for this would have to be 1 over temperature. So you would actually have to change all these values into 1 over 555, 1 over 575, 1 over 645. And then the y-axis is the ln of your rate constant. So you'd have to take all these values. So that's one way of doing it, is to take your new values and plot them, get the straight line, right? And that straight linear line has a slope. It's going to be a linear line, so it's beautiful. And that's how you get the activation energy, which is denoted as EA. And maybe what I'll do is I'll say that this is above here. So activation energy is always EA. However, this is just way too much time. And if we can do it in a formula, let's do it in a formula. So to sum all this up, to get ln of k's, 1 over t's, you have this EA over R thing going on here. We could sum this up in a formula that is this right here. Let's bring it down, and maybe we'll bring it a little bit smaller. But here it is. Now, in this, and how I knew that we were going to use this type of formula, is if I see at least 2 rate constants with corresponding temperatures. For this formula, you're basically taking 2 plots on your graph and just using it with your slope formula. So here's that EA, right? That's what we're trying to solve for. So that's the activation energy. This is your X value. And the R value is always a constant number, right? The R value is that constant 8.314 joules per mole times Kelvin. So that's why with this formula, all of your temperatures have got to be in Kelvin. Now, there's only 2 plots here, K1 and K2, T1 and T2. However, with this information, you got 4 plots, right? You got 4 points, we'll say. So if they're all going to be on this linear line somewhere, 1, 2, 3, and 4, the idea is that it doesn't really matter which 2 you take. So maybe if you want, you take 2 different ones than me. And let's see if we get the same activation energy. Ha-ha! So maybe what I'll say is, for me, maybe we'll do K1, T1, and then we'll do K2, T2. Maybe what I'll do is I'll take the first ones and the last ones. So the first plot, we'll say maybe those are K1 and T1. So maybe my K1 will be 6.23 times, and maybe what I'll do is I'll bring this over a little bit. 6.23 times 10 to the negative 7th with the T1 of 555 Kelvin. And my K2 will be the one all the way at the bottom. So 2.01 times 10 to the negative 3rd, and the T2 will be 700. Okay, so if you want, you could take these 2 values as your K1 and T1 and see if your answer is the same as mine. So now, since I have all that figured out, let's take those and plot them into this lovely formula. And what I'm going to do is I'm going to start on this side. And with this formula, you know, the ln's and the 1/overs are done for you already. So you don't have to worry about changing any of the values. The formula will do it for you. So it's going to be ln of K1, which we said, for me, 6.23 times 10 to the negative 7th, over K2, which is the 2.01, times 10 to the negative 3rd. I'm just making sure that this looks good. 6.23 times, yep, 2.01, okay. Equals EA over R, so X over 8.314 times 1 over those temperatures, right? Now, when you're using this formula, the numbers get flipped. So K1 first, K2, but then T2 comes first and T1. That's how I kind of remembered it when I was learning this formula, was that if I did K1 first, T2 has to come first. They're flipped. So in this case, blue's coming first. So 700 minus the 555. And these are already in Kelvin, so just know that these temperature values, these have to be in Kelvin. So they already did that for me, so I don't have to even worry about that. And now, what we're going to do is we're just going to solve. Now, if you have lovely Calci, right, a TI-84, TI-84 plus CE, which is the one that I have here. If you guys have a TI-89, I love Texas Instruments. You can plug these all into, you know, single shot. So what I'm going to do is we'll take this whole thing and simplify this down to one number. So what I'll do, maybe I'll say, okay, so I'm going to say natural log ln of 6.23 second comma, that's the EE button, times 10 to the, and now all I got to do is negative 7 divided by 2.01 times 10 to the negative 3rd, close those parentheses. And I'm just making sure that I plugged in everything good. 2.01 looks good to me. Press enter. And you get your first number, negative 8.079. Equals, this I'm just going to keep as it is, right? So, you know, maybe we'll just box this off. We'll say, okay, I'm not really going to do anything with that right now. And then the next thing, you can do this all in one shot. So 1 divided by 700 minus 1 divided by 555. Press enter, and there you go. So now this whole thing, there we go. So this whole thing now is going to be multiplied by negative 3.73 times 10 to the negative 4th. So now we're at here. We can simplify this by saying that, hey, here is a number, and it's being multiplied by the x value. So these go together. So maybe what I'll do is I'll just kind of put like a little break there, and we can say negative 8.079 equals negative 3.73 times 10 to the negative 4th times x, right? That's what we're still solving for, divided by the 8.314. Now we just have simple algebra, right? Cross multiply the negative 8.079 times the 8.314. And maybe, let's see. So I'm going to take this value. I'm going to grab the whole value just so that we don't round. Times 8.314. Press enter. We're getting down to it. Negative 67.170, I guess we'll say. Equals negative 3.73 times 10 to the negative 4th x. And now solve for x. Oh boy. Can I move this up a little bit? Let's see. Right, can I move? I can move this up. Oh yeah, we're getting room. We're getting room. There we go. So divide by the negative 3.73 times 10 to the negative 4th. Divide by negative 3.73 times 10 to the negative 4th. This will cancel. And now I'm just going to not round again, so I'm going to take that full number and divide it by the negative 3.73. Press enter, and there we go. So maybe I'll put it up here. X equals, and what was X? That was your activation energy. So EA was, I guess we'll say 1.80 times 10 to the 1, 2, 3, 4, 5. Okay, now, if we are leaving it here, and maybe what I can do is, oh boy, this is going to be a close one. Let's see. Can I move all of this over? Oh yeah, we'll keep it like right there. So the R value will dictate what this unit's going to be in. The rest of the units are joules per mole. So that's where we're at right now. We have an activation energy of 1.8 times 10 to the 5th joules per mole. But the idea here is that they want it in kilojoules. So we can go from joules to kilojoules per mole, right? Joules to kilojoules, all you got to do is just divide by 1,000. So just take this number, divide by 1,000, and there you go. So I guess 180, right? And that is your activation energy. So your EA equals 180, or yeah, 180 kilojoules per mole, and that's it. If you wanted the 3 sig figs, you would have to put a decimal after the 180. If I don't leave the decimal, that's just the 2 sig figs. But yeah, no one cares, right? Nobody cares about sig figs. 180, that's fine with me. Anyway, I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel, and I look forward to helping you in more questions. Love helping you guys out, and I'm so glad that this channel is helping you guys out in your classes. Check the channel out. We also got physics and math videos at the moment with more subjects coming your way, so stay tuned. All right, I'll talk to you soon, okay? All right, bye-bye.